Tips for a skilled teacher. A skillful teacher helps children develop the higher order thinking skills needed to participate in discussions that expand their thinking, like outside of the box. Materials used to help students understand common fractions will also help them understand the meaning of equivalent common fractions. Encourage children to find the pattern that develops for an equivalent class of fractions. An equivalent class contains common fractions that are names for a given part of a whole. Children can easily tell if a fraction is greater than 1, so have them use 1 as a benchmark. Children can tell that 5/9 is greater than 1/2 by doubling the numerator of each fraction and then comparing the results to its respective denominator.
We're now going to talk about rounding decimal fractions. A major goal of mathematics is for children to reason as they work with numbers. One aspect of reasoning is the ability to judge whether answers make sense. The ability to round decimal fractions empowers children to make estimates to determine whether their answers are reasonable. Number lines help children learn to round whole numbers and decimal fractions. To round a decimal hundred to the 10th, children apply a rule similar to the one they use for rounding tenths to whole numbers. We are now going to tell you 3 websites that we found that can be helpful for these concepts.
The first one is called FunBrain, www.funbrain.com. The teacher could use this website, the FunBrain, to help students either practice their fractions or reinforce what the student already knows. On funbrain.com, there are 3 levels for the teacher or the student to choose from regarding their level of skill, which is easy, medium, or hard. And this could be used for the student that is struggling, or it could also be used for the student that has learned how to do what the fractions and is getting bored.
Our second website is softschools.com. The website softschools.com is another website that a teacher could use in a couple different ways in the classroom. The games on the websites could be used to either reinforce what the student already knows, practice for the student, or even differentiate methods for the student who has grasped a math concept already or for the student who needs some extra practice. Also on this website, there are quizzes available for all areas of math and grade levels, as well along with worksheets. The student can do a self-assessment of their knowledge after playing fun but educational math games.
Another website we found was ixl.com/math. This website allows the teacher to pick the grade level and area of math that needs to be worked on. The student is given a problem to work on. If the answer is not correct, the problem is broke down step by step so the student will see how to work it and they can try to work it on their own.
We are now going to show you a YouTube video that shows a teacher teaching how to use decimals and fractions.
Now that we know the basics of how decimal numbers work, let's see how we can write some special fractions using decimal numbers. I'm going to call these fractions base 10 fractions because their bottom numbers are all powers of 10, like 10, 100, or 1,000. Let's start with this fraction, 1 over 10. Well, you should recognize that it's one of our building blocks, and this should be easy to write down as a decimal number because we have a number place just for counting tenths. So all we have to do is put a 1 in the tenths place, like this, 0.1. Now when you write decimal numbers, it's important that you always include the ones place. But since we don't have any ones, we just put a 0 in that spot. The 0 makes the decimal point easier to see. Alright, so that's 1/10. But what if we have 2 over 10 instead? Well, all we have to do is change the digit in the tenths place to a 2. So 2 over 10 equals 0.2. In fact, we can keep counting tenths like this. 3 tenths, 4, 5, 6, 7, 8, 9, and finally 10 tenths. But look what happened when we got to 10 tenths. Now we don't have a digit for 10, so we had to use the next number place over, the ones place. But that makes sense because if you have the fraction 10 over 10, that makes a whole and the value is just 1. Of course, we don't really need the 0 in the tenths place to write 1, but as long as the decimal point's there, at least we won't confuse it with 10. Alright, tenths are pretty easy, but what about hundredths? Let's start with the hundredths building block, 1 over 100. To write that as a decimal, we simply put a 1 in the hundredths place. We also need to put a 0 in the tenths place to act as a placeholder and show that we have no tenths. And we still need to put a 0 in the ones place as usual. Next, let's try 200ths. For that, we simply put a 2 in the hundredths place. Let's keep on counting with hundredths just like we did for tenths. 3 hundredths, 4, 5, 6, 7, 8, 9, and 10 hundredths. But look what happened when we got to 10 hundredths. Just like before, we have to use the next number place to the left, the tenths place. This happens because any time you have 10 of a building block, they combine to form one of the next biggest building block. For example, 10 hundredths is a tenth, 10 tenths is a 1, 10 ones is a 10, and 10 tens is 100. Now the next fraction after 10 over 100 is 11 over 100. Now if you think about it, you'll see that 11 hundredths is really just a combination of 10 hundredths and 1 hundredth. Knowing that will help us write it as a decimal. Because a group of 10 hundredths is equal to 1/10, we put a 1 in the tenths place. And we still have that 1/100th left over, so we put a 1 in the hundredths place. There, 11 over 100 is just 0.11 as a decimal. Fortunately, you don't have to break up the fraction into tenths and hundredths each time. Anytime you have a 2-digit number over 100, all you have to do is put those digits into the tenths and hundredths place of your decimal number. Let's look at a few more examples to help you see the pattern. 24 over 100 would be 0.24. 32 over 100 would be 0.32. 78 over 100 would be 0.78. And 99 over 100 would be 0.99. Now, what do you think will happen if we convert the fraction 100 over 100 into a decimal? Right, 100 has 3 digits, so we need to use another number place. Now, the next one over is the ones place. And that makes sense because 100 over 100 is a whole, and its value is just 1. Now that we know how to convert hundredths into decimals, let's try converting thousandths. That's fractions that have 1,000 as the bottom number. Let's start with 1 over 1,000. Now this should be easy. All we have to do is put a 1 in the thousandths place. Notice that this time we need zeros in both the tenths and the hundredths place to act as placeholders. Next, let's try converting 10 over 1,000. Remember that 10 thousandths is the same as 100th, so we'll put a 1 in the hundredths place, and we'll put a 0 in the thousandths place. We don't really need the 0 at the end, but it helps us see that this was 10 thousandths. All right, what if we have 100 over 1,000? Now that's a 3-digit number on top, so we're going to need to use 3 number places: the thousandths place, the hundredths place, and the tenths place. So as you can see, 100 over 1,000 is just the same as 1/10. Let's see a few more examples. 58 over 1,000 is 0.058. 73 over 1,000 is 0.073. 365 over 1,000 is 0.365. And 999 over 1,000 is 0.999. And finally, what do you think we'd get if we converted 1,000 over 1,000? Right again, 1,000 over 1,000 is just a whole, so its value would be 1. Okay, so we've learned how to convert base 10 fractions into decimals, but we can go the other way too. We can start with a decimal and convert it into a fraction. Let's say we want to convert a decimal number into a fraction. All we have to do is take the decimal digits and make them the top number of a base 10 fraction. The bottom number will be determined by the smallest number place used in our decimal. For example, to convert 0.8 into a fraction, we put an 8 on the top and a 10 on the bottom because the smallest number place in our decimal was the tenths place. And to convert 0.29 into a fraction, we put a 29 on top and we put 100 on the bottom because the smallest number place in our decimal was the hundredths place. And finally, to convert 0.568 into a fraction, we put 568 on top and 1,000 on the bottom because the smallest number place in our decimal was the thousandths place. Okay, so far, all of the fractions that we've converted to decimal numbers, and vice versa, have bottom numbers like 10, 100, or 1,000. Those fractions are easy to convert because our number system is based on powers of 10. We have number places specifically for counting those. But what if we want to take fractions with different bottom numbers, like 1/2, 3/4, or 8/25, and write those as decimal numbers? We don't have special number places for halves, fourths, or 25ths, so what are we going to do? Well, you're going to have to watch the next section to find out. But first, let's take a minute and review all this. If a fraction has a bottom number that is a power of 10, then it's easy to convert it into a decimal number because there are number places just for counting base 10 fractions. To convert tenths, all you have to do is put the top number in the tenths place. To convert hundredths, you have to use both the tenths and the hundredths place together. To convert thousandths, you have to use 3 number places, and so on. You can also convert from a decimal number to a fraction just by making the decimal digits the top number of the fraction and by using a bottom number that's based on the smallest number place from our decimal. Be sure to do the exercises so you get really good at converting base 10 fractions.